So let's use the program first with a very basic example, the IMU data from my phone. Those data from my phone are very easy, are nine values for the IMU: acceleration, angular velocity, and magnetometer. The actual frequency of the data is 52. We have only one element for each row. It was placed on the pelvis, and then the first element for acceleration is position 1. For the gyroscope is in position 4, and for the magnetometer position 7. And what I need to do here is to change this, because I was working, my phone is getting the information in degrees per second, so actually the conversion will be like this, but I know that I have to increase this number to get a 360 degrees turn. And then I run the code. I can see here the result of the acceleration and gyroscope. We can see that I was turning around the y-axis. And let's see the results are here. So we have the quaternion created, the file IMU after the filtering and rotation. We have no rotation and filtering here, but we have the result and the movement and placement. Then we will see in Opensim the result of those files. Let's open a model first. And then with this model, I'm going to place the sensors. The sensor is only one here. Placement. I'm going to apply 90 degrees turn and pelvis to align my sensor was pointing in this correct placement position. Then I will run the movement. Again, let's turn this, and then let's run the movement. Okay, and it works. We have just with a very basic IMU from my phone converted to quaternion and then to movement. Great. So let's go now for a much more complicated example. Let's select the files. In this case, the data are much more complicated. We have 2 data for timestamp, and then we have 8 IMU data for each row, and we can configure this here. So 8 data for each row. The placement is correct. The first data for the acceleration is position 3. The change of units in this case is centimeters divided by square seconds. So we need to convert this. We need to convert also to radians, and this is the correct conversion in this case for the units that we have in our IMU. It's very important to know the units of your IMU, and then I'm going to apply all. We have all this in correct. I run the code, and I can see the acceleration and the rotation for each element. Suppose the correction, the angular velocity to be higher, the calcaneus part. But for example, if I feel that I have a lot of noise, I can correct my data. I can go here, then I can filter, for example, all of them or only one. Then, for example, if I filter the data, we see the result of the acceleration is quite different. So we can change these parameters to create some different IME files and then different quaternions, and the result will be different. In this case, we are not going to apply filtering. Let's see the result. We have the movement, placement, and all the data. Movement file. It's the classic configuration. Opensim. And then if we go to Opensim to see the result, let's go to Open Model. Let's go to placement. We need to align our sensors to the Opensim alignment. In this case, our sensors were pointing in this direction, but we have seen that we can rotate the sensor if needed, and then let's run the movement. Again, we need to rotate and then movement, and then let's run the movement to see it's small steps.